Welcome to the Laboratory of Terrestrial Ecosystems Management. I'm Hitoshi Shinjo, Professor of this lab. Currently, we have Assistant Professor Makoto Shibata with 8 students as research student, master course student, and PhD student. Most of them are international students coming from Indonesia, Vietnam, Nigeria, and Ecuador. First, let me explain our vision and major activities. Our continued life depends heavily upon terrestrial ecosystems that include air, water, soils, plants, and animals. At the same time, we also influence the functioning of terrestrial ecosystems and act as one of the components. The recent increase in human activities adversely affects ecosystems and the environment at both the local and global scale, in the form of desertification, water and soil pollution, and land degradation. Our laboratory is engaged in a broad range of studies on terrestrial ecosystems management. The study topics include soil characterization, soil fertility mechanisms and maintenance, the utilization and conservation of soil resources, the mechanisms of soil degradation and its remediation, and the reappraisal of indigenous agroecosystems management techniques in the humid and semi-arid tropics. We also take holistic approaches for rural development and ecosystems management that can be used to enhance human welfare and security in Japan, Asia, and Africa. Now, let me explain some examples of our research activities. First example is from Niger, West Africa. There, wind erosion is the major process of desertification. First, we have established the trial plot to accurately monitor the sediments lost from a field cultivated with pearl millet, major staple crop, and found that amount of the nutrients lost by wind erosion are 2 to 3 times as much as that of crop uptake. Then, as the countermeasures to control wind erosion, we have established the fallow band system. This system requires 5-meter fallow band in every 50-meter cultivated zone. The fallow band can trap soils blown from the cultivated zone, and in the succeeding season, crop can grow better thanks to the nutrients trapped in the former fallow band. Our trials have proved the tremendous impact of this system with 5 to 7 times yield increase in the former fallow band compared to the continuously cultivated part. Next example is also from Africa, Malawi. Malawi is a landlocked country in southern Africa, and their majority is smallholder farmers. Due to the rapid rise of the fertilizer price, they cannot afford chemical fertilizers enough for their field despite the government support for subsidizing fertilizer procurement. To address this issue, we have developed the project Environment, Livelihood and Sanitation Nexus with the support of JICA, Japan International Cooperation Agency. Focusing on the human waste as underutilized resources, we offer technical support to build the urine diverting dry toilet that can sanitize human waste and allow them to use it as fertilizer. Our activity is not only for that. We offer the technical support on how to use it for crop production and how to sell the harvested crops in the markets to realize their better livelihood. We have seen the increasing number of the farmers adopting this technology, particularly after they witness its significant impact on crop performance. Let us move to our studies in Asia. In the central highlands of Vietnam, strongly weathered soil called feral soils is widespread on basaltic plateau. This region is a major coffee growing area, making Vietnam the second largest coffee producer in the world. However, the increased use of chemical fertilizers, especially phosphate, has raised concerns about water pollution. Our research focuses on reducing the use of chemical fertilizers and minimizing environmental impact while keeping productivity high by using locally available organic resources like coffee husks. In the central mountainous areas, acacia and cassava are widely grown on steep slopes. these areas face serious soil degradation due to erosion. We aim to develop effective land management practices to reduce soil loss and improve sustainability. By addressing these challenges, our work supports sustainable farming practices that protect the environment and help local farmers maintain their livelihoods. Tropical peat, which is widely distributed in the coastal lowlands of Indonesia, has been rapidly developed for the cultivation of the commercial crops, mainly oil palm. It can be a source of carbon dioxide gas. We are conducting research aimed at the rational use of tropical peat to reduce such environmental impact. The last example is from Japan. In Japan's hilly and mountainous regions, agriculture faces big challenges. The workforce is getting smaller and older, and there are more abundant cropland. We also need to reduce carbon emissions and fertilizer use for the environment. Our research focuses on promoting eco-friendly and value-added agriculture using local resources. For example, in Hinohara village, Tokyo, we study native local soybean varieties that grow well with less fertilizer and reduce nitrogen leaching. In Kyoto, at the terraced paddy fields of Shugakuin Imperial Villa, we use methane fermentation digestate, a byproduct of energy from livestock manure, to reduce chemical fertilization in rice farming. Our goal is to develop sustainable farming practices that tackle these regional issues and help protect the environment. By doing this, we support both the land and the people who depend on it, ensuring a productive and eco-friendly future for agriculture. Now, Assistant Professor Dr. Shibata is going to introduce our lab facilities.
We do not study only in the field. We collect soils, crops, water, and air samples from the various fields and bring them back to the laboratory for chemical analysis. We evaluate soil fertility by examining soil pH, organic matter content, clay content, and plant available nutrients. We also analyze plant nutrient uptake, nutrient loss to the environment, and greenhouse gas emissions. From these results, we understand the biogeochemical cycles of carbon, nitrogen, and phosphorus, and establish sustainable land management practices. Now, I will introduce the equipment used for our analysis. This is an ICP used to analyze concentration of metals like iron, aluminum, silicon, phosphorus, nickel, and cadmium in soil extracts and water samples. It helps us understand soil composition and the behavior of harmful elements. This XRD device studies soil mineralogy through X-ray diffraction. Clay minerals affect nutrient retention, pH buffering, and cation exchange capacity. They also influence soil structure and water retention. Understanding these properties helps optimize soil fertility management. This elemental analyzer determines the carbon and nitrogen content and their isotope ratios in soil and plant samples by burning them at 1000 degrees Celsius. By measuring stable isotope ratio, we can trace the origin of organic matter and identify the sources of nitrogen absorbed by crops. This HPLC device analyzes cations and anions in water samples like soil solution, rainfall, and river water. It helps us study the leaching of nutrients like nitrogen, potassium, and calcium from agricultural land, aiding in the development of better crop management practices. This gas chromatography device measures greenhouse gases such as carbon dioxide, nitrous oxide, and methane. Studying these emissions helps us develop strategies to reduce them, supporting sustainable farming practices and informing climate policies. Here is our soil stock room. where we keep samples collected from various countries, including tropical Asia and Africa. The soils are air-dried, sieved through a 2mm mesh, and stored. We take samples as needed for our analysis.
Hello, my name is Tasha Stefani and I am from Indonesia. I enrolled in this program with Asian Development Bank Scholarship, and my motivation to join this laboratory because the lab offers hands-on research opportunities, allowing me to work on cutting-edge projects related to terrestrial ecosystem, and this is aligned with my ethical and moral values of protecting and preserving natural ecosystem. And my research focuses on system of rice intensification. It's a strategy for growing rice under regulated water management. And SRI is recognized for its potential to meet the rising food demand while ensuring water security and maintaining environmental balance. In my future career, I aspire to work with international organizations such as World Bank or Asian Development Bank, particularly in roles related to IFC safeguards. And I believe this program and laboratory will provide me with the knowledge and experience necessary to achieve these career goals.
Hello everyone, my name is Cornelis Sandi from Malawi, currently a third-year doctoral student in the Terrestrial Ecosystems Management Lab, where I also completed my master's from 2016 to 2019. My major is Global Environmental Studies, and my research focuses on sustainable soil management by understanding soil properties and using eco-friendly technologies for agriculture production. In this lab, I have gained extensive knowledge, skills, and experiences from my professors and colleagues. It has also provided me with opportunities to network with people worldwide, fostering future collaborations. My career goal is to continue research in agriculture and the environment, seeking better solutions for agricultural improvement without compromising ecological functions.
Hello everyone, my name is Diệu. I come from Vietnam and I am first year PhD student here. I have received the mixed scholarship from the Japanese government. My research focus on using a coffee husk on the coffee plantation for increasing the carbon sequestration in the soil, decreasing the nutrient loss, especially nitrogen, and avoiding the overuse of chemical fertilizer in cultivation. I am deeply appreciative of this change and will utilize it to address the environmental issue in my research site, my hometown, while also fostering a strong connection between Vietnam and Japan.
We will welcome you to our laboratory. We are waiting for your contact.